Okay, so yesterday we were talking about the pH scale, what is an acid, what is a base, and we talked about how H plus is just a proton, so it piggybacks right onto water, and it forms this new hydroxonium ion, H3O plus. Everybody remember that? Yeah. Okay, and then we kept going and we talked about where did those numbers all come from? Where did the pH number come from?
14.
And we found out that we could do some math with it, and it's all about the logarithm. Come on, go down. Go up a little bit, up just a little bit. Anyway, there's your first formula. So your first formula is pH equals negative log concentration of hydrogen. And we played with that log button in our calculator. Remember that? Good. The second formula then was the opposite of that. Quiet. The second formula was the opposite of that. So the opposite of log is 10 to the power of. And so therefore, if I'm figuring out the H plus concentration, it's 10 to the power of negative pH. And we played with that in our calculator. Oh. Okay. And then we looked at the fact that a strong acid fully ionizes and what that means in picture form. And a weak acid partially ionizes. What did that mean? Only some of it breaks apart and the rest stays together. Okay? And we learned that water actually partially ionizes as well, and a teeny tiny little bit of it becomes H plus and OH minus. Most of it stays together. We don't write that in our dissociation equations, like the net ionic that we were doing before, because not enough of it matters. But when you start looking at pH, it matters. So we've got to think of it here. And that we came up with a third formula, and you might have to do this by yourself one day, so you need to be paying attention that this formula here, hello, come on, please. Yeah, there we go. That this formula here, although it's highlighted in blue, so we'll just have to suffer through that. 1.0 times 10 to the power of negative 14. That's another formula that can then figure out how much OH minus is involved. And if it's just water, it should be neutral, right? Mm-hmm. And so I should have just as much H plus as I have OH minus. And so if H plus and OH minus are the same, then they equal each other. And so plugging equal values, let's call them both X then, into this equation. Now that's X times X equals 1.0 times 10 to the power negative 14. X times X is, well, X squared. So X squared equals 1.0 times 10 to the power of negative 14. And how would I solve for X? Square root both sides. So square root that side, square root this side, and I end up with X equals 1.0 times 10 to the power of negative 7. What was X again? Oh yeah, these things. And how do I figure out pH from those things? pH equals negative log concentration of hydrogen. And you just said that that number is this. Negative log 1.0 times 10 to the power of negative 7. And if you remember from yesterday, pH was always that number there as long as this was 1 times. And so the pH is 7. And so in junior high, you just went neutral pH 7. Okay, this is where the scientists got that number from. This is how they gave neutral things a pH of 7, because of that math there. Everybody following me? Are you awake yet?
Oh yeah.
Okay. So, POH is where we are starting today. If I can get this video or this screen. So POH. How do I stop highlighting? Okay, I'll just do that. So POH is the opposite scale of pH. So if I have the two scales are opposite and they go from a scale of 1 to 14, then the total of them should equal 14. So if I have something that's really acidic, tell me the pH of something really acidic. 1. 1. Okay, so pH of 1. What's the pOH then? 13. So a pOH is the exact opposite of pH. So a really low pH meant a strong acid, right? So a really high pOH means a strong acid still. Strong acid pH is low and the pOH is high. They are opposite scales of each other. Okay? Everybody with me? Isaiah, you are highlighting, underlining, annotating, and engaged. Thank you. All right? Everybody okay with that? So there's another formula for us on here. Okay, so now the fifth formula is pH equals negative log concentration of OH. And at this point you're going, how many formulas have I got to memorize? Right? Okay. But this formula is exactly like the first formula I showed you. The first formula I showed you was pH equals negative log H. See that? H and H. So now I'm saying we can go pOH equals negative log OH. So basically I take that out and put an OH there, take that out, put an OH there. See that? And in Chem 30, you're going to do pKa equals negative log, what do you think?
Ka.
Negative log Ka. Okay? Do you see? So what P means is negative log. So I can put anything in here as long as it's the same thing there. So it's not a very different formula. Okay? And because the opposite of log is 10 to the power of, then this formula applies as well. The concentration of OH minus equals 10 to the power of negative pOH. Just like the concentration of H plus equals 10 to the power of negative pH. You see how these formulas are the same? Yeah? And this button in your calculator, log and 10 to the power of, is the same button, just with a second function. So again, it's not something you can kind of find. So although this looks quite like a daunting long list at the beginning of this unit, you will find that they're all so similar, actually quite quick. Okay? So here's a list of all the formulas. pH on the board here, pH negative log concentration, there's another one, there's another one, there's another one, there's another one, there's another one. The students from last period found it very helpful to have just a list, boom, that they could look at. So you might want to jot this list down too. And then we can conquer some examples together. Okay, so I'll give you a couple seconds to write that formula down. Okay, so first example. If they tell you pH is 3 and they ask you what is the OH minus concentration, what do? Okay, so you know the pH. Everybody okay with that?
Yeah.
What formulas do I have that involve pH? pH equals negative log H plus concentration.
That's the one.
So I could find H plus concentration. Everybody all right with that?
Yeah.
Okay, so let's try that. So, how do you find H plus concentration? You actually do this way, right? You actually do H plus concentration equals 10 to the power of negative pH. So this equals 10 to the power of negative 3. Because pH is 3, everybody should have said 3. Everybody agree with that? And do you need to put that in your calculator? No, because it'll come out as 10 to the power of negative 3. Okay. which is 1 times 10 to the power negative 3 is 0.001 if you really want to. Moles per liter. Okay, can I go from this to the OH minus concentration somehow? Can anybody see a formula that'll work for us? Can anybody see a formula that goes from H plus concentration and it'll give us an OH minus concentration? Cooper says the bottom one. The bottom one looks like this. Yes?
Yes.
This is what I'm looking for, right? This is 10 to the power of negative 3. Can I find what I'm looking for?
Yes.
Yeah, you bet I can. Divide both sides by 10 to the power of negative 3. Or actually, just remember from math, when I multiply integers, I add them. Right? When you're multiplying exponents, pardon me, wrong country. When I'm multiplying exponents, you add them, and so the OH minus concentration will be 1 times 10 to the power of negative 11, because 11 and 13 make 14. 11 and 3, I mean, make 14.
Can you just use this one then?
Okay, so, okay, everybody okay with that? Moles per liter. Everybody understand what I've done? Everybody happy? Okay. I'll address your concern in a second,
Okay.
Broden. I want everybody to learn how to put this in your calculator properly, okay? Because mistakes are made in all sciences because students insist on putting times 10 to the power of 11. And when your calculator, who innately knows BEDMAS, sees these as different, that is different than the 1, it gets it confused. Is everybody okay? So like I had a Chem 30 student who insisted on writing times 10, like actually hitting the multiplication, hitting the 10, hitting to the power of. She was getting every single question wrong. She's like, I don't know what I'm doing wrong. And it wasn't that she didn't understand the material, it was that she was putting it in her calculator wrong. So you have to learn to use this function. Instead of times 10 to the power of, you need to use the E button in your calculator. Oh, that's a big eraser. Okay, so 1, instead of times 10 to the power of, it's E negative 14. The E button is above the 7, there's a comma, second function comma, you see these 2 E's. So you can put in 1 second, oh, I gotta turn this on. Sorry. 1 second comma, so now I see an E, negative 14, divided by 1 second comma, so I see an E, negative 3, enter, 1 E, negative 11. Did everybody get that? Are you getting a U on yours, Max? Okay. Everybody good? Okay, so you have to switch. Instead of putting times 10 power up, if this belongs together, you put the E. If I don't actually mean I'm multiplying 10, put the E. Okay? Make sure the calculator understands that they belong together. All right, so now Broden's saying to me, oh, I wouldn't have used these formulas. I would have done this a different way. And there are different ways to get to the same answer. So when you're working with your friend, don't worry about where you've started. In fact, never worry about where you started. Because every formula on here will get you to the right answer. This might take you 3 steps instead of 2. It might also take you 2, but you've used 2 different formulas. So Broden, what formula did you want to use?
OH minus equals 10 to the power of negative POH.
10 to the power of negative POH. I'm looking for this. Have I got POH?
Well, you can figure it out easily.
I can figure it out easily. What would you have used to figure it out?
Just 14 minus 3.
Right, so pH plus POH equals 14. I know the pH is 3, so that equals 11 to get me my 14, so POH equals 11. So then I can plug the 11 in here, and that's 10 to the power of negative 11. Is that not what we got? Oh, I didn't put the answer in, sorry.
Yes.
Did we not get 1 times 10 to the power of 1 times 10 to the power of negative 11 over here too? Right. Do you see how Broden's method works exactly the same as the first method? Let's look at the right answer. Why? Because they're all the same formula, just written different ways. So they all relate to each other. Okay, so they're different pathways. Okay, so the next one. What if we have a pH, hydrogen concentration equals 1 times 10 to the power of negative 9. What is this an acid or base solution?
Base.
Cooper says base. Why?
Because the bases are greater than 7.
So explain your bases are greater than 7.
Yeah, pH.
Well, that number is pretty small, 1.0 or 0.000001. That's what that number is. It's not greater than 7. You're right. Just explain yourself properly.
Well, the exponent is greater than 7.
Okay. And so what did you learn in junior high that was greater than 7 and made it a base? The pH. So to show your work, I'm going to need to convert this into a pH. So how do you do that? How do you convert that into pH?
Negative
pH
log.
equals, good, negative log H plus concentration, which equals negative log 1 times 10 to the power of negative 9. Everybody all right with that? And the pH equals? Cooper knows. He's already told you guys.
9.
9. And so, is it acidic or basic? Basic, as is junior high. Okay? What about this one? Which you can't see so obviously. If the OH minus concentration is 1.2 times 10 to the power negative 3, what is the pH and what is the POH? Think you can do this one on your own?
Yep.
Okay, have a go. I'll give you 1 minute. Fasten, where did you start?
I did POH equals log to the power of negative OH.
Okay, so it's negative log, and it's not to the power of, it's just negative log concentration OH.
Okay.
Okay, almost as if it was timesing it, but it's not. It means you're taking the log of OH. Okay? All right? And so that equals negative log of 1.2 E in your calculator, right? But we don't write E. 1.2 times 10 to the power of negative 3. And so I should get an answer close to 3. Everybody okay with that? Should get an answer close to 3. But not exactly 3 because it's 1.2, not 1. So Bassam, what'd you get?
I didn't quite finish it.
Okay. 2.9? 2.9 is the POH. Is this so far a strong acid or strong base? Strong base, because pH is the opposite to pH, right? So strong base. If this is a pH, it'd be a strong acid. Okay, so strong base. Okay, so 2.9. And that tells me the POH. Good. How do I solve for the pH then? What did you do, Josh? So you did this formula. Oops. pH plus 2.9 equals 14. And Josh, you got? Hands up if you got those two answers. Good. Hands up if you did exactly the same thing I've done on the board. Hands up if you did something different than what I've got on the board, but you still got the same answers. Oh, everybody did it that way? Spencer?
No, I got the first nice definition right.
Okay. Okay. Everybody feeling comfortable? Okay. Let me get you started on this sheet because the sheet's laid out quite differently than these kind of questions. And at first it looks like they're different questions than you can do, but they are the same. The first thing it does is it gives you the compound as opposed to just H plus. So for this, we have to be thinking about our dissociation or ionization equations. So if HCl is dissociating, or when it dissociates, when it ionizes, what does it make? H plus and Cl minus. So if I have 1 times 10 to the power of -3 of this moles per liter, how much do I have in my H plus? Remember this from a few days ago? The ratio is 1 to 1, so therefore it'll be the same. Good, I can hear you muttering those sort of things. And now you're looking at me like, well, why have you done that to us? It's just the same. But if it was H2SO4, my ratio would all of a sudden be 2 to 1, and I would have had to multiply this by 2. Do you get that? Mm-hmm. So if it was H2SO4 and it was 1 times 10⁻³ of H2SO4, I get 2 H pluses. And so 1 times 10⁻³ moles of that is equal to, well, 2 times 10⁻³ moles of that. Okay, so it does matter. All right, so then, how can I figure out my, oh dear. 1 times 10⁻³ Oh, fancy. How do I figure out the OH minus concentration? Pardon? Can't subtract by 14. Yeah, I'm using that bottom formula there. OH minus times H plus equals 1 epsilon -14. Not that you have to write that in there, but anyway. So therefore it's 1 times 10 to the power of -11 moles per liter. Moles per liter. And my pH must be? Nope. 3. How'd you get that so quick, Josh? I didn't even see you pick up your calculator. Because of what Cooper said earlier, this to the power of is the pH as long as that's 1. Right? Okay. And then, is it acid, base, or neutral? Acid. And should it be an acid? It's hydrochloric acid. It should be acidic. Okay? Have a go at the second line. I'll give you like 2 minutes, and then I'll take the answer on the board. Okay, so that means you've got, this will dissociate into Na plus and an OH minus. So 1 mole per liter is 1 mole per liter of that. So this is 1.00 moles per liter, or if you fancy this, 1 times 10 to the power of 0 moles per liter. And so therefore, what is your H plus concentration? 1 times 10 to the power of -14, because 14 and 0 is 14. If you're not loving these exponents, you can always put in your calculator. It just takes you a little longer.
Yeah.
pH is then 14, and this is a base. And it should be, because it's got an OH. Sodium hydroxide is a base. Now hold on a minute. What we've just learned is that if I make up a solution of sodium hydroxide base, I have an itty bitty little bit of H pluses. Well, where did those come from? Josh? The water. Because what did we learn about water? A teeny tiny bit of it dissociates. Right? And our hydrochloric acid, did it not have a little bit of OH minus? Our hydrochloric acid, did it have some base in it? Yeah. Where did that come from? Where did that come from? Water. So water, HOH, is neutral because it's 1 part H plus and 1 part OH minus. Only a teeny tiny little bit of it. Okay? All right, NaCl. Where are you going to start? -2. Where'd you pluck that from? Oh, okay, all right. So this number here is the same thing as 5.0 times 10 to the power of -2. Is that what you're saying?
Oh, yeah.
Okay, fine. What does that got to do with this? Josh? It is neutral. This dissociates into what? Na plus and Cl minus. Where am I going to put this number? Could I put it here? No. Could I put it here? No. Oh dear, now I'm stuck. This isn't like the first line or the second line. And then somebody puts on their logical hat and goes, it's salt water. Isn't salt water neutral? Aren't ionic compounds not acids, not bases? They're neutral, right? And so therefore, if this is neutral, what must the pH be, my grade 7s? 7. Okay, now comes the hard part. Okay? So if the pH is 7, can I now calculate these two? How? Right. So if the pH is 7, then this is 10 to the power of negative pH. So that means it's 10 to the power of -7. Right? And this is also 10 to the power of -7 because of the formula H plus times OH minus equals 1 times 10 to the power of -14. Okay? Or they're certainly going to be equal because it's a neutral substance. And by neutral, by definition, means I have as much of this as I have of that. So those two are equal. This is just a -7, not a... Okay? Okay. So, these three have been very different, but the rest of them are very similar to these three. So you should be okay. Have a go. When you're done those, we're going to do these SNAP booklet questions. At the bottom here they're listed. And I want you to just please do the odds. This is our last, well, I like to say this is the last thing we're learning before the exam, but you might have to learn something else because you missed it or you didn't understand it or whatever. But I have taught everything that we are doing in this unit now. Okay? So from here, after these bit of practicing all of these kind of questions, then we're going to do the practice problems at the back, and then we'll be ready for a solutions test on Tuesday.
Will the test be multiple choice or?
It'll be a mixture of everything, like all the other ones have been.